Good morning to all. In today's session, we are going to discuss one of the important topics in the C programming language, that is the storage classes. We know how to declare variables in C, and we know how to define functions in C, right? So when we declare a variable like, let me take an example that int x. So this particular declaration says that I am going to declare a variable x which is of type integer. And this also gives that x holds the integer values because of this data type. And it also tells that the total size that is occupied by x is equal to 4 bytes. All these things we have seen in the earlier discussions, right? But in today's class, we will also discuss the storage classes of the identifiers. We know that an identifier is a name that is given to a variable or a function or an array or a structure, whatever it may be. Any name we will be calling it as the identifier in C. So when we declare some variables or when we declare some functions, at max these storage classes will be taken with respect to the variables, and when we declare these variables we need to specify we need to have some information related to these variables, like what is the default value of these variables. Similarly, what is the scope of these variables? I'll tell you, we'll discuss everything, what is mean by scope and what is mean by default value, and we also have to know some idea about the lifetime of the variables. So what is the default value, what is the scope, what do you mean by the lifetime? When we declare a variable, all these information will be given by these storage classes. So storage classes are a concept that is introduced in the C programming language, which gives the information related to the identifiers. What type of information it is going to give is, it specifies what is the default value of that particular variable. It also specifies what is the scope of the variable. It also specifies the lifetime of the variable. So all these three important information will be specified by the storage classes. I'm just giving a gist of this storage classes, right? So this is the purpose of the storage class. Now let us see how many storage classes are there. There are 4 storage classes that are supported in the C programming language. The first one is the automatic storage class. The second category is the register storage class. The third one is the static storage class, and the last one is called as the external storage class. These are the 4 storage classes that are supported in C programming language. So for each and every storage class we will discuss what is the default value of the particular storage class, and what is the scope of the storage class, and what is the lifetime. Everything we will discuss, right? And before entering into the actual discussion on the storage classes, we will see everything with one example also. And before going into the discussions of the storage classes, let us give some idea on what a scope is. So a scope is nothing but the region. It specifies the region, the part of the program. So the scope specifies the region over which you can access the variable, from which part of the program or from which instruction of the program to which instruction of the program you can access the particular variable. The region of the program is specified as the scope. In the same lines, the lifetime of the variable. The lifetime specifies the time over which you can access the variable, or you can access the value of the variable, or you can also say that the variable is alive, up to what time the variable is alive. So you just remember these two terms regarding the scope and lifetime. Scope specifies the region and lifetime specifies the time period. So let us move our discussion into the storage classes. So as I told that a storage class determines the part of memory where the variable is stored. This is very important, right? Why do we specify the storage class? In addition to this default value, the scope and lifetime information, it also specifies where the variable is stored. In general, we know very well that variables are stored in the memory. So we have two types of memory, that is the primary memory and secondary storage. Remember that when we consider the term memory in our textbooks or wherever we find the term memory, it is basically related to the primary memory. It is not related to the secondary memory. Though we are categorizing it, the memory, as the secondary memory and primary memory, when we refer to the term memory, it is basically referring the primary memory. And the secondary memory, we call it as the storage. So if you hear the term storage, then it is indirectly referring to the secondary memory, right? So remember that memory refers to primary storage only. So let us come back to our discussion. Where these variables are stored? We know that variables can be stored in the memory. Memory in the sense they are stored in the primary memory. This part is very much clear. We know everything about it. But there exists another storage location where we can store the values of the variables. That is called as registers. So what are these registers? Registers are a special case of memory, a special part of memory that are exclusively present. These registers are present in the CPU. So what is the purpose of these registers? Since the registers are maintained in the CPU itself, whenever you access the contents from these registers, you will be accessing them in a faster manner when compared to that of accessing the elements or the values from the memory, main memory. So for example, if you take this as a CPU chip, within the CPU you have some registers like this. This is a vague example I am giving. And assume that on the entire motherboard we have the CPU here. This is my motherboard. And CPUs, the registers are present inside the CPU. These are the registers. And on the motherboard we have some memory, that is primary memory. And this CPU and primary memory are connected with some data lines and control lines like this. So if you look at this diagram, it will be very clear that when the CPU wants to access the contents from the primary memory, it has to give some instructions to access these values, and there exists some delay. It has to send a command to the primary memory, and the primary memory makes a search over here, and the data will be sent to the CPU back again. So all this overhead is involved in accessing the contents of the primary memory. But when you store the content in the registers itself, since the registers are located on the CPU itself, there is no delay of accessing the elements from the registers. So to have the faster access of elements, you will be storing the elements in the registers rather than the primary memory. So if you consider the secondary memory is stored somewhere in the CPU. This is my CPU and this is my secondary memory. In order to get the contents from the secondary memory, again it has to send the commands all the way to the secondary memory. It will search for that particular location based upon the address, and the contents are fetched back to the CPU. So the delay that is incurred in fetching the details from the secondary memory is very greater than the fetching of data from the primary memory, whereas CPU registers, you can access it on the fly, like instantly you can get these values. So to reduce the delay that is present in accessing the elements from the primary memory or secondary memory, you will be making use of the registers, right? But remember, the storage of these registers is very less. If you consider the secondary memory storage, it will be around 1 terabyte. And if you consider the primary memory, now we are having some 8 GB or 16 GB like that. But if you consider the registers, they will be very less in terms, they will be in the terms of megabytes, not in the gigabytes also, right? So you should always keep an eye on the memory that is given to the registers. Very less memory is given to the registers. So don't ever try to push every variable into the registers. So do not push everything onto the registers. This is very important. Never ever try to push all the variables onto the registers. Why? Because there is not sufficient memory to hold all those values. Then you may have a doubt, what values or what variables do I need to push into the registers? Means whatever variable you are accessing frequently accessed variables. Whatever variables you are accessing frequently, those variables can be kept inside these registers or stored inside these registers, so that you will get you can have access to those variables very faster manner, right? So for this purpose you are going to use the registers. So there are two types of memory. The storage class, as we have discussed, that it is going to store, it will tell where you are going to store the variable. So we have two types of storages, the primary memory and the registers. In most of the cases, automatic variables, static variables and external variables, every variable will be stored inside the primary memory only, except the registers. The register variables will be stored in the registers that are readily available in the CPU, but these points you have to keep it in mind, that registers have very less memory, and don't try to push everything into the registers, and you need to push only those variables that you need to frequently access. So when you keep the frequently accessed variables in the registers, it will not incur any delay, so you can have those variables in a faster manner. This is the purpose of registers, nothing more than that. So whether we are going to store the variables in the memory or registers, this will be given by the storage class. The information along with the default value, scope and lifetime, it primarily specifies where we are going to store the variables, whether we are going to store it in memory or registers. That is the main purpose. Next. And the storage class also defines the initial value of the variable. So what is this initial value? That is nothing but default value. While discussing in the previous sessions, when we declare a variable like this, int x is a variable of type integer, and we know that this is a declaration statement and memory will be allocated like this. And while discussing itself, I told that while you declare the variable and after creation of memory for that variable, the default value that is being stored in this variable x will be some garbage value. Right. Like that, if you consider these four storage classes, one is the automatic, another one is register, another one is static, and the last one is external. Out of all these four variables, the auto and register, they will be having the default values as garbage values. Whereas the static and external, they have the initial value or the default value as 0. So we have only two default values, whether it can be a garbage value or it can be a 0. If you consider the auto and register, they will be storing the garbage values initially, whereas if you consider the static and external, they will be storing the default value as 0. Right. And as I told that the storage classes also specify the scope and lifetime of the variables. So four types of information it is going to give. The first one is where it is stored. The second one is default value. And the third information that it is going to give is scope. And the fourth information is lifetime. So these four types of information will be given by the storage class. So if somebody asks you what is actually is a storage class, a storage class gives the information related to the variables. What type of information it is going to give? So that storage classes, they try to give the information where it is being stored, what is the default value, scope and lifetime, right? So as I told that there are two storage locations in computer, one is the CPU registers and the second one is memory. Memory in the sense it is always treated as the primary memory. And I told you the reason why we need registers. The value stored in the CPU register can always be accessed faster than the one that is stored in the memory. So to have the faster access of the values, we will be storing some values in the registers. That is the only purpose we have. Now let us see what is the scope of a variable. As I told that the scope is defined as the region, the part of the program. We can also say that it is part of the program. From which instruction to which instruction, or the portion of the program where we can access or where we can refer the identifier in the sense here we are taking it as variables. From which part of the program to which part of the program we are going to refer the variable, that is given as the scope of the variable. Right. So some identifiers, they can be referenced throughout the program, right? So throughout the program you can refer them. So those variables we are calling it as global variables. We have seen the difference between the local and global variables. Local variables are declared within the function, global variables are declared outside of all the functions, and global variables can be accessed by all the functions, whereas the local variables can be accessed by only that particular function. So the identifiers which can be referred throughout the program are called as global, whereas some identifiers they can be referred within a particular portion of the program, right? From one block. You can make a block in the C programming language by using this curly braces. We know this everything, right? So for this purpose, within the block you can access, or within the function you can access. All these things they go as the local variables. So when you declare a local variable in a block, it can be referred only in that block or in the blocks nested within that block. I will give you an example also, nothing to worry, right? So if you have a block like this, and if we have another block, nested block like this, if I declare a variable int I in this block, this particular I can be accessed from this part where it has been declared to end of this bracket, right, curly brace, right? Similarly, this can be also be accessed within this part, within this block. Why? Because this block, the inner block, is nested inside the outer block. So all the variables that are declared in the out block can also be accessed in the inner block. So you can see here, from this part to this part, you are having the scope of this variable I. So all this region, you can refer the variable I. Now let us have a discussion on the lifetime of a variable. I have given you a hint that the lifetime specifies the time period, the period of time over which you can access that variable, or over which the variable is alive. Whenever the variable is alive, then only you can access it. Without the variable, without having a variable as live variable, you cannot access it. So simply remember that the lifetime of a variable simply specifies the time period of a variable where it is alive, where you can access the value in that particular variable, right? So similarly, local variables, when you declare a variable as a local variable, we know that it is declared within the function. So until unless you execute the program or that particular function, let me take one function f like this, and within this function I declared a variable x like this. Scope is from here to here, that is a different case, it specifies the region. But lifetime means from this point onwards it has taken its birth, so it is alive. So x is alive from the point where it has been declared, and from that point until unless when the function gets executed, it will be alive. Once you come out of the function, it will be dead. So these are the two important points you have to understand. So when you call the function, f, memory will be allocated. So when the memory will be allocated, when you execute the function and when the compiler comes at this particular point, memory will be allocated. And you can make use of this variable within this particular scope. And when you function, when you come out of this function, the memory will be deallocated automatically. Here it takes the so here you have the allocation, and when you come out of the function, it will be deallocated. So when the memory is deallocated, we say that the variables are dead. When the memory is allocated, we say that the memory is taken its birth and it is alive. So from this point to this point, the variable x is alive. So don't get confused with these two terms, scope and lifetime. Almost they appear similar, but scope specifies the portion of the program, whereas the lifetime specifies the time period of the variable where it is alive. So when you take the variables that are declared inside the function, when you call the function, variables are activated, they are alive. When you come out of the function execution, the variables are dead. Please keep these two important points in mind. So with these introductory concepts of what these storage class is, what information it is going to give regarding the variables, where we are going to store, what is the default value, all these things, what is scope and what is lifetime, we will actually go into the storage classes that are supported by the C programming language. As I discussed that the 4 types of storage classes that are supported by C programming language is automatic variables, register variables, static variables, and external storage class. So these are the 4 storage classes we have: automatic storage class, register storage class, static, and external. Now let us see each and every storage class. As I told that the auto storage class will be giving 4 important information. The first one is storage, where it is stored. The second information it is going to give is what is the default initial value. The third information it is going to give is what is the scope of those variables, and the fourth one is what is the lifetime of those variables. And in addition to this, we will also discuss what is the keyword that is used to declare those variables. So for every storage class, automatic, register, static, and external, we will be discussing these 5 points along with a simple program to have a good knowledge on the storage classes, right? So the keyword that is used to declare a automatic variable is auto. And remember that this automatic variable is the default storage class. The default storage class. What do you mean by default storage class? So when you want to declare an automatic variable, you have to precede the declaration. For example, I have a variable int a. Let me take an example, int a. So a is a variable of type integer. We know everything about it. But when I want to make it as automatic variable, I have to use the keyword auto, which is to be preceded before the declaration of this variable. So I precede it with auto. So I want to declare an automatic variable in this particular syntax. Auto followed by int followed by a. That is the identifier. And I say that this is the default storage class. Default storage class means though you don't specify the auto, you just specify it as int a and float f. These variables f and a, though they are not having the storage class, not specifying the storage class, they are automatically taken as the automatic variables by the compiler. That is the reason why we say that the automatic is the default storage class. Don't specify any keyword before the declaration. They will be treated as the automatic variables automatically by the compiler. Right. So we call it as default storage class. And the storage where these automatic variables are stored is the primary memory. And the default initial value for these automatic variables will be garbage values. So till now, whatever we have seen the programming part, we will be declaring a simple term like int a, double d, all these things. So remember that these particular variables are the identifiers. They are automatically considered as the automatic variables. They come under the category of automatic storage class. So all these declarations, these automatic declarations or automatic variable declaration will be having the garbage values. And coming to the scope, it is local to the block in which the variable is defined. I told a block is nothing but a pair of curly braces. So when you declare a variable within these curly braces, you can have the scope is within that particular block only, or within the nested blocks also, nothing wrong in it. And coming to the lifetime of the automatic variables, the variable that is declared within the block will be alive up to that block only. So for example, I take a block like this and I take a variable int I. This is the automatic variable. So it will be stored in the primary memory. The default initial value is garbage value and the scope is local, right, from here to here. And the lifetime is till the control remains within that block. So the variable I will be alive here and until the control lies within this closed curly brace. it will be alive. You can access the value of I. That is all about the automatic storage class. Let us have a simple discussion here on a program. We know this preprocessor directory stdio.h main, and here you can see this is one block, right? This is the main block, and I am declaring a variable integer variable I, and that is declared as automatic variable, and I am initializing it to 1. At this point, memory will be allocated and it is given the name as I. Let us take the thing as base address as 100, and the initial value that is stored here is 1. If you don't specify this initialization, what is the initial value? It will be a garbage value, but you have specified the thing, right? So what happens here? Instead of garbage value, 1 will be stored here. Let me draw like this. 1. Now after this one, I have used one curly brace. That means I am specifying the block, another new block here, and that will be from here to here. See, from this opening curly brace to closing curly brace, and this is another block from here to here. And within this block, I am declaring another variable I, and it is an automatic variable. So default creation of memory I will be there, and this is a new variable which is created at another location. Let me say it is created at 200, and by default it is initialized to 2. So you can see here that the I is equal to 1. This particular I which is created at base address 100 will be accessed from this point, that is the declaration, to the end of this function or the end of this block, and the lifetime is, it starts its life at this point and it will retain that value until the control lies within this block, the main block. And if you consider the second variable I which is created at address 200, the life starts at this point and it will retain its value until the control lies within this block. And you have another block here, third block. This is third block, this is second one, this is first block. So within this third block, I am again declaring a variable. Since the block is given, therefore the memory allocation will be different, and it is storing a value of 3. You can see here that they are having the same variable name I, but since they are declared in different scopes or different blocks, the I's are given, the 3 different I's are given 3 different locations. You should understand that point, right? So within the same block, for example, if I want to declare int I is equal to 2 in the first block, this is not accepted. Why? Because you cannot have the same variable names within the same block, but you can have the same variable names within different blocks. That is the reason why this I is different from this I and this I is different from this I. 3 different variables, though they are having the same name as I. So within this block, the third block, auto int I is created and it is alive from this point until the control lies within this block. And at this point I am printing the value of I. In the previous discussions, while we are discussing about the differences between the global and the external and the local variables, the local variables will be having the preference. So when you try to print the I within the third block, it will print the value of I is equal to 3. Why? Because the I within the scope of this block is this third I which is created at 300. Therefore 3 will be printed at this point. Now when you come out of this third block, you exit from this one, this I will be dead. You cannot access this I. And when you come out of this block, you are in the second block, and you can see here that the I is equal to 2, which is created at address 200, will become active. Why? Because the scope is still there, the lifetime is there, and when you try to print this one, it will print the value of 2. And when you come out of the second block by exiting from this curly brace, this variable which is created in the second block, I is equal to 2, will be dead. That means the lifetime is completed for this variable. And the third one is printf %ld I. So you are in the first block and you want to print the value, you will be printing the value of I is equal to 1. And at this point you can observe that I is equal to 2 is dead, I is equal to 3 is dead, but still you are in the first block itself. Therefore at this point also the variable will be alive. But when you execute the last curly brace of block 1, you can see that the life of this first variable I is equal to 1 is also dead. So this is how the automatic variables will work. You simply observe that the scope is within that block and the lifetime is within that block only. So when the control retains in that particular block, the variable will be alive. When you come out of the block, the variable is dead. That's all about the automatic storage class. Let us go our discussion into the register storage class. So the keyword that is used to declare a register variable is register. So if I have a variable int I like this is an automatic variable. Why? Because the default storage class is automatic. But if I want to store this I in the register, I have to precede the declaration of the variable with the keyword register, this one. This is how you declare the register variable. So when the compiler looks at this particular register keyword, it will come to know that the user is trying to declare a variable and he wants to store it inside the CPU register. So that is the purpose of this register keyword. And we know that the storage is within the CPU register and the default initial value is also garbage value. So when this is a declaration statement, memory will be allocated within the CPU register. Everything is similar, but instead of creating the memory in the main memory, the memory will be created in the CPU registers. That's the only difference, right? And it will be having the garbage value. And the scope is local to the block within which the variable is defined. So when you declare this register variable within a block, the scope will be from the point of declaration to the end of that block. Similarly, the lifetime of the variable will be from the point of declaration till the control remains within this block. When the control goes out of this block, then the variable will be dead. This is what we have to understand. Let us go with the programming part. Right. So this is the preprocessor directive. I have the main function. See here the declaration of the register variable. So normal declaration int I, which is preceded with the register keyword. And at this point for I is equal to 1, I less than equal to 10, I plus plus, printf % I. So it will print the values of 1 to 10. But this is a normal program, right? Even though you don't write this register, it will print the output as 1 to 10. There is no difference. But what happens here is when you try to execute with the automatic variables, try to get the execution time with the automatic variables. Let us say that the execution time, this is for an example, if the execution time of this particular program takes 10 milliseconds, and when you calculate the execution time with the register variable, it will take some 5 5 milliseconds. This is just for an example to understand the concept, right? So the execution time when you store the variable inside the register will be less when compared to that of executing the same program with the normal variables. So if you have some tool to access the execution time, you can measure it. Obviously, the execution time for executing the program with the register variables will be less than the same program with the normal variables. And that completes the discussion on the register storage class. Now we will move our discussion into static, very important concept, right? Static storage class. So the keyword that is used to declare the static variable is static. So when I want to make a integer variable as static, you have to use the keyword static, and it should be preceded before the declaration of integer variable or whatever variable it may be, irrespective of the data type. Whenever you want to convert a variable into the static, you have to precede it with the static keyword. That's it. And the storage of these variables, static variables, will be in the primary memory only. Except CPU registers, all the three storage classes they will be stored inside the primary memory only. And here you can observe very important point. The default initial value of the static variables will be 0. So if you declare a static variable, memory will be allocated and it will be given the name as I, and instead of garbage value what we have seen in the concept of automatic and register variables, the default value will not be garbage, it will be 0. It will be 0, right? And the scope is almost similar to that of the local variables, right? Like the automatic and register, the scope is local to the block in which the variable is defined. So if you declare a variable, static variable like this, the scope will be from this point to this point within the block. And the lifetime is similar to that of automatic and register variables. Its value will be retained, and this is very important. It is within the block, the lifetime of the static variable is not within the block, right? So when you come out of the block, the values will not be dead. This is very, very, very important. This is the only difference between the static variables and the remaining variables. So for the remaining variables, the lifetime will be unless the control lies within the block. But what happens to the static variables is the lifetime of the static variables will retain during the function calls also. That means you can see here, the lifetime is the value of the variable persists, therefore it retains its value between the function calls. I will tell you with an example. So the lifetime, very important, this is very important. The lifetime of static variable is the value of the variable persists between the function calls. And this is very important program. Please concentrate. So this is my preprocessor directives, and you can see here that there is a function called increment, and this is called as function prototype. The other name for function prototype is function declaration. Why we are going to declare the function means, in order to give some information related to the function to the compiler, prior information is given by this particular function prototype statement. So when the compiler comes across this statement, it will come to know that, oh, within this program, the user has given a definition for a function with name increment, which has a return type of integer. I didn't specify any return type here, but why I am saying it as integer? Why? Because the default return type of any function, will be integer. So here the increment is the name of the function, the return type is int, and it does not accept any parameters. This information will be given to the compiler. So after this we have the main, and you can see that I am just all these three statements 1, 2 and 3. All these three statements that I mentioned inside the main is just the function call. So for the first increment function call, what happens is the control jumps from this place to the function definition. You can see here that this is the function definition. You won't get any warnings here. Why? Because increment is already declared. So the compiler knows that the function increment is there somewhere else in the program. So it will not give any warning. So the control will jump from this point, the function call, to the function definition, and it starts its execution. This is very important. Please concentrate. So as the first statement in the increment function, I have declared an integer variable I. Okay. Therefore memory will be allocated 4 bytes of memory, and I am naming it as I, and let me take the base address as 100. Right. And I am making it as static. So what happens when you give this as static means initially the value will be 0. So the default initial value will be 0. But what happened here? Instead of 0, they have initialized it to 1. Very good. And now I am trying to print the value of the static variable I. So the value that is present inside the I is 1. 1 will be printed. Very good. Next, I will be incremented. So I becomes 2. So the static value, the static variable is incremented from 1 to 2, and then it will come out of the function after executing this, and the control will return back to the calling function. Here it will be written. Now after this, see here, at this point you should observe one important point. So when you complete the execution of the function, normal variables, they become dead. But since it is a static variable, you told that please make my variable I as static. So when you request the compiler to make the variable as static, you are asking him, or you are asking the compiler to please retain the value of the variable I during function calls. Right. So at this point, when the control is returned back from the called function to the calling function, you observe that the variable I is still alive. This is still alive. It is not dead. But this doesn't happen in the other variables like the arithmetic and registers. When you come out of the particular block, when the control comes out of the block, the variables will be automatically deallocated. That is dead. They will be dead. But since you requested the compiler to make this variable as static, when the control come out of this particular block, you can observe that variable will not be dead. The allocation of memory will not be taken. So the deallocation doesn't happen. So it still retains its value. Very important point. And after returning back, you can see here that there is another increment function call. So again the control will jump from this point to the function definition. Okay. Now see here, another important point you should observe. When you go into the increment function for the second time, the first statement, that is static int I is equal to 1, will not be executed. Very, very important. So when you make the variable as static, two important things you have to observe is, it will be initialized only once. Throughout the program. So the first time you have initialized it to 1. But for the second time when you call the function, this statement is being skipped by the compiler. So no initialization takes place here. This will be skipped. Why? Because the static variables has a property that they will be initialized only once. After this will be executed. So printf %ld I. What is the value of I have? It is 2. Therefore 2 will be printed. And then I will be incremented. So the value of static variable I becomes 3 here. And when the execution is completed, the control will return back to the calling function at this point. And you can observe that the variable is still alive. The memory is not allocated, the memory is not deallocated, it is still alive. And the next statement is the another function call for increment. Therefore what happens here is, again the control jumps from this point to the function definition. And when you go into the execution of the increment function, you can observe here that the first statement, which is the initialization of the static variable, will not be executed. It will be skipped for execution by the compiler. That is the property of static variable. The property is initialization of static variable happens only once. And then you execute this statement, so 3 will be printed and I++, therefore it becomes 4. And after execution, again the control will go back here and still the program retains its value. That is, the static variable retains its value. And there are no statements further in the main program. So the main will be executed. At that point, this variable will be dead. This is how the static variable execution happens. 2 important points about static. The first one is the static variables are initialized only once. The second point, very important point, is it retains its value. It retains its value during function calls. Please keep these 2 points in your mind. So if somebody asks you whether you know something about the static variables or not, they will be expecting these 2 points to be explained by you people. So be careful, please. Very important point. Please make a note of this one. Very important point. Please make a note of this one. Right. So after this, let me discuss the last storage class, that is the external storage class. The keyword that is used for the declaration of external variables is the extern keyword. So I declare it like extern int x. And remember, I will tell you one more important point here, right? Remember that the external variables are always initialized with some value. You cannot leave the external variables like that. Declaration is not enough. For external variables, see here, we have 2 things: declaration and definition. We know declaration of a function, we know the definition of a function. But what is the declaration and definition for the variables? Very important. So the declaration means you just declare it like this. You don't give the initial values. But definition means you initialize it. X is equal to some 2 or some value. So initialization of a variable, external variable, is called as definition of the external variable, and just declaration is the declaration. And coming to the storage, the external variables are stored inside the memory. And coming to the default value, it is 0. So that x variable will be stored in the primary memory and it is having a default value of 0. Now the scope of these external variables is global. We know the meaning of global. You can access these variables from the point of declaration throughout the program. That means you can access them throughout all the functions. See here, the scope is global, means you can access it throughout the program. Within the block, within the function is different. Within the block means from here to here. Within the function means from here to here, this one. But within the program means you can observe that there is a program called p.c. You have some functions f1, f, g, h, like this. So you can access these global variables throughout all the functions. F, G, H can access those well. Similarly, the life is as long as the program's execution does not come to an end. So the life is throughout the program. So if you declare an external variable, that variable will be alive until you complete your execution of the program, not the function. Very important. So these 2 points you should keep it in mind. So the scope of the external variables will be throughout the program, and the lifetime is throughout the program. Very important part. Let us have a discussion on the programming part. So this is a preprocessor directive. And this you can see here. Here I am declaring an external variable x. Right, this is a normal variable and I am preceding it with extern keyword, therefore this is an external variable. And you can see that the initialization is done here. Therefore 32 will be initialized. Even though you don't initialize, it will be default value will be 0. Right, but definition is mandatory. Right. And here you can see that second variable, int b is equal to 8. This is also a global variable, right? Why? Because it is declared above all the functions. So anybody can access it. But this is a automatic variable. So this becomes b is equal to 8. See here, this one. So within the main, I have an automatic variable, therefore a it is 28. Now you can see, I am just making use of the extern int b. This is a declaration. So when I make use of the declaration, you can see here I am not making any assignment here. What does it mean? Means it will tell the compiler that the extern keyword will tell the compiler that b has been declared here, but it has been defined somewhere else. So go and check the entire program where it has been defined. So this is nothing but it is referring to this b is equal to 8. And when you try to print the value of automatic variable a, since it is a local variable a, it will print 28, nothing wrong in it. But when it wants to print the external variables x and b, so x it is initialized to 32, therefore 32 will be printed. But what is this b? This b is a variable, external variable that is declared here, but it is defined at this place. Therefore it will access this external variable and it will print the value as 8. And now in this particular statement what I am doing, I am just modifying the initialized value. X is equal to 15. So I know this x is an external variable, therefore this x is equal to 15 will directly refer to this particular location. So instead of 32 it will become 15. Now if you try to print the modified value of external variable x, okay, that is modified and 15 will be printed. So this is how the external variable will work. But keep it in mind that the extern keyword is used to extend the visibility of the variable. So what is the purpose? Main purpose of extern is it will extend the visibility or the scope, you can say, visibility of variable. So the main purpose of this extend keyword is it extends the visibility of the variable, right? But we are not going to use this extend keyword for the functions. We are going to use this extend keyword for the variables only. Why? Because By default, the functions are visible throughout the program. So if I declare a function f here and if I declare another function g here, this is visible throughout the program and g is also visible throughout the program. So there is no need to define extern functions, right? Although you don't specify it as extern, they are visible throughout the program. So if you put an extern keyword before this function, you are just making it as a redundant thing. But variables, you need to make them as external. You have to specify them externally. So that if you specify the extern keyword for the variables, the extend they will extend the visibility, this one, of the variable. Right. So initialization of external variable is considered as the definition of external variable. Right. I told you, right? So this is called the definition of external variable. So these are the some of the important points regarding the external storage class. Right. So that completes the entire concept of the storage classes in C. Just to have a gist and recap of what we have discussed till now. We have started our discussion with what a variable is, what information is given by the data types, and then we have seen what a storage class specifies. A storage class specifies where the variable will be stored, what is the default value of the variable, what is the scope of the variable, and what is the lifetime of the variable. And we have seen what is a scope. A scope specifies the period, a scope specifies the region over which you can access the variable, and lifetime specifies the time period of the variable for which it is alive. And then we have gone through the discussions on the 4 storage classes that are available, that is automatic, register, static and external. Automatic variables declared with keyword auto, storage is memory, default value is garbage, scope is within the block, life is within the block. And we have seen the program also. And then the register storage class, keyword is register, storage is CPU register, and the default initial value is garbage, scope is within the block, life is within the block. We have seen the program also. Remember that registers variables are used to store to have the faster execution of the program. And 2 important points regarding the register, please keep it in mind that the registers have limited memory, so don't try to push everything into the registers. Whatever variables that are needed for that are frequently accessed can be put into the registers to have the faster execution of the program. And the third storage class is static, which is defined with the keyword static. Storage is within the primary memory, default initial value is 0, and scope is within the block, but the life is, it persists its value between the function calls. This program we have seen, very important point. The static variables are initialized only once, and it also retains its value during function calls. These 2 important points you should keep it in mind regarding static. And the last storage class is external storage class, defined with the keyword extern. Storage is within the primary memory, default initial value is 0, scope is throughout the program, life is throughout the program. Right. So you should keep it in mind that external variables are always initialized with some default value. That is called as the definition of the external variable. So by this we will put an end to our discussion on the storage classes. Thank you one and all for joining the session.